Okay, well, hello, and welcome to another Energy Code webinar topic. This one is about the Commercial Energy Code, and it is I'm going to emphasize the word very, Ali, a very brief overview of the mechanical code. I'm Mike Barcik, and with me is my colleague, and we're going to kind of just give it a kind of a lick and a promise, but I always like to remind people, bigger picture. You have a choice in the commercial world. You can do either the 2015 IECC. There's a couple Georgia amendments there, and some of those pertain to the mechanical. And there's also ASHRAE 90.1, which we probably tend to focus a little bit more on. So Ali, I realize a lot of people maybe wonder what we look like, so I thought I'd show a picture. That's really, you're rocking that sweater. That's a good look on you, I gotta say. So I realized too, I forgot to figure out what I need to jump on ahead in this presentation, and I'm going to show you where you the listener can download all these slides and use them and help you to solve your problems or see all this information. Up right about there is where I want to be. So for the mechanical code, so that that's slide 181. Let me make a note of that. And I want to make sure, Ali, that we show everybody how to get this. So I'm going to say, I know you're supposed to go to southface.org. Then what happens?
Yep. So from there, when you get to our homepage, you're going to see a top menu bar. You'll see that in just a second. Right there where Mike's mouse is hovering.
Okay, there's the home page, right?
And then that top bar says About Us, Program Services. Hover over Education and click on Our Courses.
Our Courses, okay.
And then from there, if you scroll down, you're going to see a collapsible menu for Energy Code. Go ahead and expand that. And then when you scroll down, you're going to see one for Georgia Energy Code and Support Documents. So that's where you're going to find this presentation. That's where you're going to find all the resources that Mike's going to mention on this webinar. You can find them all there.
Yeah, and actually, while I'm thinking about it too, I did want to mention we had done some research. So if you go into, so I'm going to come back to this one, the one that you mentioned. If you go into resources, under technical resources, there is some commercial building research that we did called Advanced Commercial Building Initiative, ACBI. And if you expand that under resources, you'll see a whole bunch of things, case studies, and how to do blower door testing in commercial buildings, envelope, combustion safety. Here's a good one we've talked about for envelope upgrades, you know, sort of a checklist of details, things you should pay attention. Here's one on HVAC controls. And again, plug loads, stuff like that. So how to use Energy Star Portfolio Manager. Procedures for doing an energy and water assessment on a small light commercial building. So there's some good information here. It's all free, and please take advantage of it, including water heating and so on. So I wanted to point that one out. And then if we go back to where we were under Education Courses, and I'll click on Energy Code, Georgia Energy Code and Support Documents, this is what you were referring to, is all this good information here.
Yep.
The description of the grant. A lot of this is like residential. There's some videos about residential. Hey, there's a picture of us.
That's how we actually.
That's how we actually look. And then I thought the Starsky and Hutch was a good look. You're not wearing your sweater over here. So yeah, here's where you can download all the slides for the commercial energy code training. And I just will admit up front, apologies to the HVAC community. We just did not have the bandwidth to really do as much as we wish on the HVAC portions of the code. It's, you know, it's one of those ones where you kind of have to be in that industry to really do it. But if you read it, you kind of like follow the rules. And there's no trade-offs to be had. It's just do this. And so I'll cover that in a little more detail. But this is kind of an example of that. There's also this really useful thing called the Commercial Field Guide, which I had up here a second ago. I sure have a lot of these open, don't I? Commercial Field Guide looks like this, and I may even refer to it a few times, but it is looking at you can download it and download it in Spanish if you prefer. It's got a lot of information about the components of the building envelope, and then down here it talks about HVAC, and there's a simple compliance option. If you can say yes, no, not applicable on 18 items, you're done. And a little bit about water heating. That's it for a lot of small commercial buildings. That's really all you need to do. So this is one advantage of using ASHRAE 90.1 over the IECC, is they have this simplified compliance for HVAC approach. So we might, click on that or go look down at that, and I might just slide down here and see if I can find it. It looks like it's about right there. So, nope. But I'm close. I got to be close. There we go. So it does say mechanical here. I kind of wish it said HVAC simplified approach. So this is the option that we'll talk about. And in a way, the field guide might be a better way to learn this. So we'll take a look at that. But I'm going to do it from the slides. So here's where we started. Again, the slide 181. And we have a couple things that we included just to kind of tie in, sprinkle in some of our research and stuff. And, it's kind of one of these interesting things. Some people don't believe that setback saves much energy. And the answer is it saves a tremendous amount of energy. If you can shut equipment off or set it back because no one's in the building, this is a great way to save energy. And as long as your system recovers before people come back, which it should with a programmable thermostat, this is a really good opportunity. We particularly like this brand of thermostat has been interesting because it includes an occupancy sensor. So we had people telling us that it tracks, so people say we can go back and look at energy bills, say for Saturday, and you go, well, according to this, your air conditioner ran all day Saturday, and someone says, yeah, well, we were working on Saturday, and it says, well, it says, according to this, you were only there 2 hours. So kind of keeps people honest, but it really can help you figure out why are you using energy when you don't need it. So that's kind of neat. In terms of the major changes between the 2007 version and the more current 2013 90.1, really not so much big changes. One of the big chunkier parts of the energy code is these tables and tables and tables of efficiency, and they're still there, and they've been updated, and they've included a few additional types of equipment in there. But it's basically saying you need this minimum SEER air conditioner or this minimum EER and so on, and most equipment you buy probably satisfies it, but that's a big chunk of the HVAC chapter is those tables. It's kind of interesting because in Georgia, you can either use 90.1 or you can use the 2015 IECC. And if you pick the IECC route, it's got its own set of tables. But Georgia decided to delete the ones in the 2015 IECC and everybody uses the same set of tables. And if you think about it, it kind of makes sense because you hate for a piece of equipment to sort of pass under one code and fail under another code. And think about the nightmare that could create. So we're just going to use ASHRAE equipment efficiency tables. Should be fine. There's a couple fan efficiency requirements, but not really anything major. I would say one of the newer things is they've tweaked a few things on controls for cooling towers and boilers. A lot of it is they're saying there's some good things that you have to do now under certain cases. We're going to try to get you to do it in more cases in the future code. Energy recovery is a good example, or demand control ventilation. Those are good things. But really, again, nothing earth-shattering on any of this stuff. I would say they have increased scope. They're including walk-in coolers. Some of that is new. Some of the big built-up refrigeration warehouse kind of places. They're putting some efficiencies on that. But again, nothing really earth-shattering from the way the code is today, just a little bit of increase of additional equipment and maybe a little bit of additional application. Okay, what do the two energy codes have in common in terms of HVAC? They all want load calcs to be done. And according to IECC, you got to size to the load calcs. ASHRAE is a little more flexibility, but you got to do the load calc. And for, as I mentioned, the minimum equipment efficiency, and again, we're always going to use the tables out of ASHRAE 90.1 for Georgia. That was an amendment. Ducts have to be sealed. Ducts have to be insulated. And here's the key, they have to be balanced. And balanced is usually, it says to within industry standards, and that's typically about 10%. So if your HVAC design says this register is supposed to be putting out, 150 CFM, and you test and balance, it needs to be putting out within 10% of that number. So that's an important detail. And test and balance, there's no trade-off. That has to be done on every commercial building. So that's a really important one. Virtually all of the mechanical section is prescriptive, with one small calculation, one small exception. It has to do with fan motor power. And the way I would describe it is it's like if you've got to move 1,000 CFM, they don't want you to try to shove it through a 6-inch duct. That would be incredibly impossible. But you need a big enough diameter duct so that the power to move the air is below a threshold. And we'll look at that in more detail, but I'll just say this very much favors variable speed fans. The bottom line, step back, what does the code want you to, wants you to have equipment that's variable speed so you can match the load at that point in time. So that's a big one. Very much true that, as a famous quote we love to kick around, nothing saves energy like equipment turned off. They really want the equipment turned off when no one's in the building, or at least set back. And that needs to be automatically occurring. We should not be running the air conditioner if there's no one in the building. And it needs to catch up within a reasonable amount of time when people are going to show up next. There is also a degree of functional testing, or I'll use the little word, the little c, commissioning, that is required. That word commissioning sometimes has loaded meaning for some folks. So in the 2015, the word commissioning was replaced by functional testing or something like that. So we'll see that. I thought I'd mention again this ASHRAE approach that's not in the IECC, and it could apply to literally, 8 out of 10 commercial buildings could use this as a compliance option. Basically, it's a list of 18 requirements, and if you can check yep, no, or not applicable, and you can just go down the list and comply with everything, or not, it's not applicable, then you're good to go. That's all you have to do. So it doesn't apply to all buildings. It's looking at, this is a classic example. It's a 1 or 2 story building under 25,000 square feet, and of course, all the HVAC systems have to comply, but it's pretty standard, like packaged rooftop equipment, that kind of stuff. So single zone, each system has to serve a single zone, so it's simple systems, packaged rooftop splits, things like that. The need for variable airflow is more common, and they have some tables that sort of say when that kicks in, but it tends to be higher airflow systems, so that they want them to throttle variable speed. Cooling is fairly standard equipment, packaged or split systems, air or evaporative cooled, and again, always meet the equipment efficiencies. Jump down to E, and heating is pretty standard stuff, packaged or splits, heat pumps, furnaces, electric furnaces, hot water, and again, meet minimum efficiency. So, and then energy recovery makes sense on bigger airflows. So we're going to see that kicking in as well. I'd skip D because people don't always love this, but economizers are back in this version of the code. They are essentially required for any, with a bunch of exceptions, but they're required for any system 5 tons and up, not bigger than 5 tons, 5 tons and up. So that's a lot of equipment, and it's an economizer control capability in climate zones 2, 3, and 4. A couple things. ASHRAE never required economizers in computer rooms, but the other code did. So the other code, that was another amendment that was made on the other code. You can say, I don't want economizer control, I just want to up my equipment efficiency. So if you're in climate zone 3A, you can put in an air conditioner that's 27% more efficient, and you can just not have to have economizer control. Economizer control is basically saying the outdoor air conditions are good. It's, 59 degrees outside and it's not that humid. So let's just flush that air into our building. And it's like running a whole house fan in an older house. And the advantage is you're not running a compressor. So that's the big energy savings. Certainly doesn't make sense in all situations. A good example of where it would be an exception would be a supermarket or some place we're really trying to control humidity very carefully, like a museum. It also, particularly in our climate zone, not all means of controlling economizers are allowed. It doesn't make sense to look only at outdoor temperature. You need to also look at humidity. So that's really important. So that's an enthalpy control. So economizers back in the code in general, bunch of exceptions, but get used to it. Yay, it's fun to be the messenger on this one. A couple of the other 18 items. This one's pretty easy. It needs a thermostat that you have to automatically switch it from heating to cooling, just like you have in your house. Or it's got to have, I think, a minimum 5-degree deadband if it's going to be a dual set point. They want the heat pump to always heat as a heat pump unless it gets really cold out. So you have to have lockout for your strip heat unless it's below 40 degrees. And we actually have a similar amendment in the residential code for that too in Georgia. Under the simple approach, we're not going to allow you to do reheat for moisture control. Reheat is where you have to sort of overcool the air in order to dry it, and then if you dumped it in, it'd be too cold, so you warm it back up again. And that, as you can imagine, is very energy intensive, particularly with electric resistance reheat. They're also very big on shutting equipment off. So anything bigger than 15,000 BTUs, and Ali, that's like bigger than a motel. Motel room is probably the upper limit on that. So anything bigger than that, you've got to have a 7-day-a-week programmable thermostat. That's kind of where it's kicking in. That's typical, I guess I should say. So pipes need to be insulated and protected from the elements. I've seen suction lines on equipment on the roof of a split system suction lines that were running along the roof. I was up there, it was 92 degrees, and all of the pipe insulation had just dissolved. And here it is running across this hot roof, and you could put your hand on it and it felt nice and cold. And you're like, that can't be good, because the insulation had just dissolved to dust. Remember that scene in Indiana Jones where the guy's face melts? That was kind of what happened. You never seen that movie? That's a great movie. His face melts. His face melts. But anyway, so that pipe insulation had melted away. Ducts. Okay, I think I mentioned this. Ducts need to be insulated. Really, the most you'd ever ask for is R6 in like an attic. It needs to be sealed. Again, we always want to use mastic. And your construction documents need to show that you've been balanced to within industry standards 10%. So that has to happen. No CO without a test and balance report. It needs to be a real one. Outdoor air and exhaust shall comply with dampers. Usually motorized dampers in colder climates, I believe in climate zone 3A, a lot of times they can just be gravity dampers. If you got a big room and you've got 2 mechanical systems serving it, you got to have what's called interlock. We don't want one system heating and the other cooling. At bigger systems, something over 10,000 CFM, that's going to have, that needs to have what's called Optimum Start. And this is what we used to call the Monday morning syndrome. You set the building back all weekend, and when you come in, you're going to come in at 8 o'clock on Monday morning, and instead of, normally it recovers starting at 7. Well, on Monday we might need to recover starting at 6. Just needs a little extra time for that. And then demand control ventilation is a great idea. This is one where you got particularly in a classroom or a conference room, something with variable occupancy, if it's full of people, everybody's breathing in oxygen and exhaling CO2, carbon dioxide, you put a sensor. As the CO2 levels creep up, you go, hey, there's a lot of people, bring in more fresh air. The CO2 levels drop down and or people leave the room, the CO2 levels drop, and then the damper can start to throttle back down. So it's kind of like an occupancy sensor for a space, but it's controlling how much fresh air. It really makes sense. It really saves energy. Probably the new thing is that they just want you to use it in more spaces. So it's sort of more applied, but it's already in our code. And lastly, door switch requirements need to be complied with. And a good example of that is, so Ali, we had this, I think we talked about this, there was a hamburger restaurant that had a patio outdoors. And what kind of door do you think they had between the building and the patio?
Sliding garage door?
Yeah, one of those big roll-up garage type doors. It was their look. And so when the weather was good, they wanted their dining area to spill into the patio. So that's fine, but when that happens, we wanted to make sure, and so we put a door switch so the mechanical system cannot run in the dining room if that door is open. Kind of makes sense. All right, so if you can tick the box, yes, no, not applicable on these 18 items, you're done. That's it. And a lot of these are very common sense. Probably a third of these are just pick the right thermostat, and many of them may not even be applicable. So this is an easy one. If you can't meet the simple approach under ASHRAE, sit back in your chair and strap yourself in because you get to deal with all the more complicated stuff. First of all, I want to say there's always what's called mandatory provisions or mandatory requirements. These have to be complied with. Examples, load calculations, pump sizing load calculations, and lots of control capability. These control capability are things we've already talked about: automatic setback, optimum start, blah, blah, blah. So a lot of these are kind of baked in, and it's just more sophisticated controls, but these are required. You have to have these capabilities. And again, this is kind of new. They've started working on walk-in coolers. They've got some requirements about those. That's sort of site-built, giant warehouse refrigeration plants, that kind of thing. Then after you get through, you just make sure, okay, I'm good on all the controls, and I mean all the mandatory things. A lot of those are controls. Then you go down the list of prescriptive items. So here you just kind of have to read it and say, is that in my building? Do I need to comply? Economizers, probably. Yeah, you're probably going to have to comply with Economizer Control. We talked about that. Reheat in general is not allowed, but there are some exceptions where it is allowed. So, in general, a ban, but a couple exceptions. And I'm not going to go down this list, but, for example, if you have a cooling tower, go here, heat rejection equipment, and read this section. Chances are you might need, if you have a lot of outside air, you need some energy recovery or big exhaust systems, and so on and so forth. So just kind of go to this, and again, if it's in that, if it applies to your building, follow the rules. If it doesn't, you can exempt it. Anything in here is prescriptive, so it means you could potentially show a trade-off, let's say with an energy model, and not have to do it. All right, that is the ASHRAE approach to, ASHRAE 90.1 approach to mechanical systems. Oh, and I did want to show this. I think this was good. This was the only calculation you have, and it's basically saying you can't run too much air through too small a duct. So designers need to be aware of this in the sense of we got to leave room, architects need to leave room for big enough ductwork. And it definitely incentivizes variable speed blowers, which we absolutely want. So you can do this either with the fan system, the motor, motor horsepower based on the nameplate horsepower, or you can use fan system brake horsepower. Either one is okay. It's just the same concept, just a little different starting point. And basically you get more budget, is that a fair way to say it? You get more CFM if you're variable speed, so it's going to be easier. If you're constant volume, you're going to have a bigger duct. bigger diameter duct or bigger cross-sectional area duct. And so without going into this, you know, it does kind of give you adjustments. For example, if you have a large, you know, a better quality filter, they're going to give you like a MERV 13 filter, you get additional inches of water column pressure drop adjustments. So these kind of all, you know, come into this equation. And I believe ComCheck will help you do this calculation. So I'm running out of time. I want to wrap up by saying in the IECC approach, these are all mandatory load calcs. A lot of these are equipment efficiency, control. A lot of these are very similar to ASHRAE. Economizer, fault detection and diagnostic, that's something that I think is spelled out in IECC, but a lot of these are also in ASHRAE. Outdoor heating must be a radiant heating with control. So like you know, you go to a propane fired radiant heater and you sit outdoors and eat. I did want to mention that the Georgia supplements and amendments did make a few tweaks to the IECC, and some of these are pertinent. There are no tweaks or adjustments to ASHRAE 90.1. So first of all equipment has to use the ASHRAE 90.1 tables. I think we covered that. We had a lot of comments about that this IECC was going to make us do things that were kind of dumb from an energy saving standpoint with makeup air and kitchen hoods. We were asked to delete those, and we chose to do that. Ducts have to be sealed and insulated, very similar to ASHRAE. Economizer, we added the same computer room exception to line it up with 90.1. There just was some kind of poor wording on pump isolation, so that was cleaned up. And if you do an energy simulation to show compliance, you're limited on up to only 5% for renewable energy. You can trade things off with renewables, but only up to 5%. And the word commissioning gives some people means different things, so they replace the word commissioning in the I codes with functional testing, functional performance testing. And then one last thing, that no matter what you do in the IECC, when you're all done, you're not all done. You have to do something additional. So you have to choose from one of 6 things additionally to be sort of better. So 2 of the 6 are HVAC. You can choose to inherently use more efficient HVAC equipment than the minimum, or jump down to number 5. This is a really good idea, a dedicated outdoor air system. You can bring in fresh air. This is a great option, an enthalpy wheel, for example, or any device that handles your moisture load of your fresh air separately from your main space cooling. That's a really good idea. So those could both qualify as your 1 extra. You can also do more efficient lighting, better lighting controls, renewable energy, and if you use a lot of hot water, you can use better hot water or more efficient hot water. So just don't forget that when you're all done, you're not all done. But guess what, Ollie? We're all done. So I'm going to take us back to the first slide and just say we appreciate everybody's time, and I think that's going to wrap it. It was a quick overview of the mechanical section, but you know, I think that's the high points.
Awesome. Thank you.
Thanks, everybody.